G'day YouTube, JB from Oz here. So after a lot of requests, I have put together the video here with all of the various calculations, drawings and the design elements of the gear cutting on the Shaper project. Here we see the first component of the Mandrel block, parts, materials being sourced, marked up and then preparing for the first cut on the Shaper.
Sounds like a handstand. Needs support here, I think. So there we go. See how we finish up. Quite a heavy cut. It's gone away now. And that noise has gone away now.
Once the block was squared up, we then took it to the mill to do some finishing to size, final bits of squaring off and preparing to bore the hole for the mandrel in this block. The base plate was prepared and squared up using a smaller end mill in the Clarkson Collet chuck.
Final cut for the last final. Is it still down to it? I'm just trying to file on that very quickly. File on that. That is that. Okay.
What you see here is the solid base and mounting plate, and moving on to the tooling that we prepared to bore the mandrel block. This is used in a number of steps, obviously smaller drilling through to the larger drilling and the various boring operations to get us to a very tight fit. We want this spindle, the mandrel, to be really held tightly on this block because the shaper has quite a bit of force behind it, hence the need for high precision and good accuracy. Pilot hole is drilled. We now expand to the largest drill size we've got and prepare for boring with the boring bar. Once the boring is finished, we then finish it out with the reamer to an accurate fit. Here you can see the extended Strongback on the boring tool. This just helps to add some rigidity as we plunge deeper inside the mandrel block. Here you can see the reamer being prepared to bring us onto our size for the mandrel. And now we can see by using a bore gauge that we were right on the money with this. So not only are we square and parallel, but the bore is true as well. This is all very important for the performance of the finished tool.
G'day YouTube, JB from Oz again. Just a quick update. I know I've had a lot of people asking me where this gear cutting attachment for the shaper is. Well, it is in progress. I'm going to show you some photos of the base and the block that have been put together. And we're just now looking at our final dimensions for the main shaft. The gears that we want to cut have a deeper boss than the plan would otherwise allow for at 1.5 inch. So we're going to increase this slightly to match the gears for the CVA. We've got dimensions for a collar that sits in to size up the 1/2 inch to the bore of the gear. We've got a locking piece that sits on the end of the shaft to secure the shaft inside the block. We've got the end cap here, which is bolted onto our index wheel. Then we have the index tooth arrangement, which locks into the index wheel, and based on the 154 tooth gear that we're trying to do, we're looking at probably trying to make the index wheel about 3 inches in diameter. Gives us a 1.5 mil wide index for the pin on this to lock into. So the tooth on the indexing pin is driven by the pitch circle diameter disc. So we figure if we have 1.5 mils on a 3 inch disc and we were to say put a slot of the 0.8 mils, which gives us, what's that, 0.7 mil as an actual tooth in between. And I'll look probably to laser cut these out of acrylic possibly, or MDF or plywood depending on. But that's coming together. So I think our plan of attack here will be to make the bushing for the gear, make the locking collar, turn down this end of the shaft, then come around and finish off the shaft. Do our 2 fixing holes for our index gear that sits over that. Once we've got an index gear that we know is the tooth that we're after, then we can lock in this piece here and be happy with that. And then some pitch circle discs and we should be right to make some chips. Thanks for watching.
So here you can see the blank material that we used to commence the manufacture of the spindle for the mandrel. And now preparing to thread the end clamp in preparation for final size of all the various components. Threading the nut Now that the mandrel fits neatly, we need to start working on the indexing arrangement and the pitch circle drive. So far we've been adjusting the plans as we progress to suit as our project approach changes. I threw together some designs on the computer in preparation for laser cutting the plastic components for the pitch circle disc and the index wheel. This is the plan for the 50-tooth index wheel, and the largest size gear that we expected to cut was the 154 tooth, and so we just worked through what size and what was reasonable in terms of a pin size, a gap size, and essentially dealing with the manufacturability of this particular assembly.
Okay, so here's our driven shaft into the pillow block. We've got our locking collar, we've got our spacer for the gear blank. This is the example we're using in place of the gear blank right now. Then our end cap goes on and securing nut. So this all bears down and locks this shaft up to be able to move as one piece. At this end we load our index discs on. We've got 2 pins to add in here to register the index discs. A set of 3 discs go in. We have a piece we're still making up, which is about 18mm thick piece of circle with the top cut off. I'm going to use this piece of blanking steel to make our pillow block to bolt into the top of that. Then we'll have our index pawl made up of this stock, which is what will latch into the index pin. So this assembly then slides on next. After that, and with pins out this side, the pitch circle disc goes on. We've got a guide disc, 2 pitch circle discs with a detent hole to secure into the wire, and then the final guide disc. Once that's all assembled, final clamp washer and nut comes on. So the procedure will be bolt it all up, take a cut. When we want to adjust the index position, we loosen this off, move around to our next tooth position, lock it up again, run the next tooth, and so on and so forth. This is the material for our dowel pins, that's the material for a pillow block and for the latch. And yeah, drawings, everything ready to go. G'day YouTube, JB from Oz again. So we're definitely approaching some progress. We're looking to fix onto the, I guess the knee section of the shaper with a couple of uprights. From that we're going to suspend a piece of wire in the back, which I'll show you a bit later on. The wire is wrapped around the pitch circle disc. So as the bed moves across, you can see there the gear would be coming, sorry, the cutter will be coming straight through the gear, and the gear rotates on that pitch circle diameter as per the disc in the back. You cut a tooth, then you reset the index, which rolls the gear around to the next tooth, lock it in, rinse and repeat. So we're just doing a mock-up here to make sure that we've got an overall idea of how we're going to clamp the wire, that we've got the pitch circle disc in place. We know how thick we're going to make our index wheel, which will pin into the index tooth. Sorry, the index tooth that will pin into the index wheel. This will be pretty damn firm. It's nearly a honeymoon fit there at the moment. Just got a little bit more work to do. But essentially that, if anybody was just wanting to get a quick idea of how the bed moving sideways rotates the gear, that's the action that we're looking for. Pitch circle disc sets the rotation of this. The cutter passes through the teeth. There we go. Thanks for watching.
Everything's really coming together now. This is the gear blank cut to size for the 50-tooth gear. The calculations for the size of the gear blank are detailed at the end of this video, but here we see it being loaded onto the mandrel and then supported with backing nut and attached to the mandrel spindle for the index teeth. Now we start to work on the index block end. We needed a solid mount for the index pin, but we also wanted to be able to adjust the diameter of the pitch circle, or rather the diameter of the index wheels, so that we could cut larger tooth gears. And so with a spacer block of an additional 1 inch boltable in between the pillow block and the drive, we can accommodate larger diameter gears, different diametral pitches and so forth. Here we're progressing to mock up the index pin. The pillow block is ready, the index drive is ready, and this part here is also a test of the pitch circle drive. So this is the actual component that connects to the index wheel and is rotated as the table moves left and right. After test fitting the index pin and getting a really nice positive result here, we then proceed to dowel the index pin into the pillow block and mount the pillow block onto the index drive. And here's the finished assembly. This is basically ready now to start cutting a gear. You can see the actual cutting of the gear in the director's cut, and you can also see our competition entry into Emma Ritson's toolmaking competition videos as well. Here we start to look at the particular calculations of a specific gear based on a diametral pitch of 32 and based on a tooth count of 50. We've then used these basics from the machinist's handbook and calculated the measurements that we require, both for the blank, the plunging of depth down into the tooth, the 20-degree pressure angle, and basically what we need to manufacture the finished gear. I hope you've enjoyed this. As I say, it was based on a request that we go into more of the calculations. Thanks for watching.